Okay, so what we're looking for is to find the pH. So we have 73.5 milliliters of 2.65 molar of KOH is added to 132.0 milliliters of 2.30 molar HF. And the Ka is given of HF is 6.8 times 10 to the negative 4. And find pH. So our first step is to convert to moles. So what we can do, so for KOH, it is just, remember, it's molar times liters, so 2.65 times liters. Since it's milliliters, you move it 1, 2, 3, so 0.0735. And then we get all that, and then we can set up the HF. HF equals 2.30 times, move 1, 2, 3, 0.1320. So let's solve for those. 2.65 times 0.0735. We get 0.1948 or 0.195 sig figs. And 2.30 times 0.1320 is 0.304. This is a 5, by the way. Okay, so those are our new moles. So now we can set up the equation. So I know setting up the equation may seem hard, but it's really simple. All it is pretty much it tells you what it is. So this is added, so plus that. So we can set this up as, by the way, K is a spectator, so we don't worry about it. So when we're writing the equation, we just leave it out. So we just go OH minus is added, so plus HF. HF goes to, and now if we're struggling here, we can think here. So there's one H, there's two H's, and there's an O. What does that make? H2O, water. And what's left over? What is it? It's the F, so F minus. And now we can see that this is the acid and this is the base, so the acid conjugate base, and that's what we need for the Henderson Hasselbach equation. So our initials, we can use moles, which is what we solved up here. So for OH, it's 0.195. For HF, it's 0.304. This is a liquid dash, and F minus is 0. So which way do we go? Since this is 0, we go to products, because our Q is less than our K. Okay, so now we can find the limiting reactant, or simply which one is the strong base or acid. So this is the strong base, so this is minus all of that, minus 0.195, and it's the same here, minus 0.195. Now this is plus 0.195. So the equilibrium is 0.195. This is 0, and for HF, it's 0.304 minus 0.195. We get 0.109. Now we can use the Henderson-Hasselbach equation, which, if you don't remember, it's pH equals the negative log of Ka plus log of base, which is F minus, over our acid, HF. So let's just plug all those numbers in. So the negative log of our Ka, which is given, 6.8 times 10 to the negative 4, plus log of our, what is that, moles? So just copy exactly how it is, 0.195 over our conjugate acid, 0.109. Let's plug all that in the calculator. Negative log of 6.8 times 10 to the negative 4 plus log of 0.195 over 0.109, 3.4. 3.4 because 2 sig figs. And that is our pH.